Okay, quickly get your notes if it's outside. Okay, what have you learned about gradient in lower sec? Rise over run. What else? That one is the length formula, new one we haven't learned. Y equals to nx plus c. And then the m is the gradient. This is the y-intercept. Okay, then Ravan has another formula, right? y2 minus y1 over x2 minus x1. So you find the difference of the height over the distance between the horizontal distance. Okay, so these were more or less the different types of things that you have learned, okay, in lower sec. Not just that, you also learn that gradient can be 0 if it's a horizontal line. Gradient is positive if it's upward sloping. Okay, gradient is negative if it's downward sloping. And then if it is undefined, it is a vertical line. Infinity, or you can say it's undefined. Okay? So this one is what you all have learned in lower sec about gradient. You should also know that gradient refers to the steepness of a slope. How steep your slope is. So if it's a positive slope, it's an upward sloping. Okay, if it's negative, it's downward sloping. So to recap, when you are given 2 points and you want to find gradient, you will use y2 minus y1.
I don't really understand the bottom one.
This one is 2x bracket cube plus y cube. So use SOAP. 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 And then the bottom will be x2 minus x1. So that's why you get 3 over 1. So your gradient is 3. Okay, alternatively, this is your A. This is your B.
Oh, and then you just draw a line.
So your rise is 3 units. Okay, and then your run is 1 unit. So rise over run, same thing. So depending on how you were taught, if you were taught to use rise over run, then you need to draw out the 2 points and then you find the rise and the run. Okay, if you are using formula y2 minus y1, x2 minus x1, then you don't need to draw it out.
8 is the end high and 5 is initial.
Yes. Yeah.
You use any 2 points that the line is going.
Correct. Any two. It will have the same gradient.
How about it can also be like a decimal?
Can.
2.6 and 10.
Can. Okay? So this is the formula that you have learned in lower sec already. Okay, so nothing crazy. They ask what is the gradient of a horizontal line. We know gradient is 0. So what kind of observation is that when your y value, the y coordinate is the same, you know it's a horizontal line. If you plot out the 2 points, one is here, the other point is here. So when the y coordinate is the same, they are effectively a horizontal line. So sometimes you don't even need to calculate. When you see that the y coordinate is the same, you know the gradient is 0. Okay, but when the x coordinate is the same, when you plot it out, you realize that it is a vertical line. Okay, when your x coordinate is the same, it's a vertical line. So technically your gradient is undefined. Because why? You will end up calculating gradient
So do we write this?
to be like this. We can't have a fraction dividing by 0, it is undefined. So when your calculator gives you math error, you should suspect that your line is a vertical line. That's why you cannot find the answer.
Do we write the infinity symbol?
Yeah, you can write like that, or you can just say it's undefined.
So therefore, m is equal to 6.
So the equation for the gradient is m equals infinity.
If they ask you for the gradient, you will just write undefined or you write infinity. Okay, but O-level rarely ask you this. They will ask you for the equation of the line. So when they ask you for the equation of the line, you know y equals to mx plus c, right? And this one is undefined, means that your equation is x equals to something. So in this case, your equation is x equals to minus 4. Because it is a vertical line at x equals to minus 4. So that's why we can't write equation in this way. It's undefined. Okay, so this is a recap from your lower sec work. There's nothing new that we have learned here. Okay, if you are done, you can move to the next page and do calculation of other kind of gradients. Okay, they give you 2 points each, right? You go and calculate all the gradient. Some will be 0, some will be positive, some will be negative, some will be undefined. Yeah, quick one. Just do a quick formula. This one quick one. It's just calculator exercise. Why? No, I'm teaching. Why I play music? Why? Oh, got 6, 7. Okay, anyway, when you calculate gradient, just decide one of the coordinate to be the final one initial. Always follow the same direction. So 7 minus 4, 6 minus 3. The rest is calculator's work. Okay, remember the symbol for gradient is the tiny m. It's a small letter m, not capital letter.
If the gradient is negative,
It's downward sloping, yes. Okay. Start working. Don't what, then never write anything. Or all finish. Okay, once you fix the direction, keep the direction the same throughout. -3. Yeah. E? Ayo. Okay, double check. Calculator exercise.
Is it a must to write like MAB, MC?
No need, but I just like to write. Yeah. Yeah, my triangle so awful. Okay, keep doing. They want you to find the gradient of the three sides of a triangle. Go and find A, B, B, C, and AC.
Yes.
No, just block me. Just block me.
Just do.
That's wrong. You're bullying me.
Who?
Marissa bullying me.
Why?
He's traumatizing me.
Okay, check through your answers. Some of you may reverse the order of these two. It is fine. You should get the same answer. If you don't, then something is wrong. Yep.
Why that one cannot 8 minus 5?
Which one? 8 minus 5. Also can. Then you must use minus 5 minus negative 2. Yeah. Quick, ah. This one is just calculating. I don't want to spend too much time on it. It's recap. There's nothing new here. So quickly count and check whether you know how to apply the formula.
Just draw an A vertical. Just draw an A horizontal.
Ravan, you finish? I don't know why I keep, because many years ago I have a Raven in the class. The Raven that was on the honor list. From 4A, take luggage to school one. Everything top go RI. Raven Rao.
Getting like quadrant.
I plot wrongly. 40. Oh, here. Alamak. Okay, no wonder my shape so weird. My B is here. Okay. Okay, if you are talking means you are done. I move on. Just make sure these few are correct. Okay, you need to move with me. If you want more time for revision, you cannot waste time on the easy stuff. Okay, this one can? I move on. So if you have not quickly copied the final answer, at least you can check. Don't take too long on calculation. Can Okay, next one. Okay, this is also what you have learned before in lower sec, just that now they give you the gradient, they ask you to find the coordinate. So they say gradient of the line AB is 2/3. Okay, So if we find gradient, it will be y2 minus y1 over x2 minus x1. So it is just solving algebraic equation. So this is 4. This is k minus 2. And it's equals to 2/3. So just cross multiply to solve. So k is just 8. Okay, so this one is just they give you gradient now and then solve for one of the coordinate. So nothing very sorry? Here? Simplified. Okay, next is they tell me that these 3 points, they lie on a straight line. Okay, so although they don't spell it out for you, you must infer. If these 3 points lie on the same line and we are learning gradient, what does it tell you about the relationship of the 3 points? Gradient of what? Same gradient. So gradient of any 2 points on the line should have the same gradient. So I will pick gradient probably of AC because both there's no unknowns. I can calculate the gradient immediately. So I'll pick gradient of AC should be equal to the gradient of BC. It is also actually equal to the gradient of AB. But I don't need to show all. I just need to pick a pair. So I will drop AB. I will just refer to these two. So when I find gradient of AC, I do a y2 minus y1, x2 minus x1. And then gradient of BC, I will do the same thing. y2 minus y1, x2 minus x1. So just set up the equation. This is a 6 and 9. This is a 6. So go and solve normally. So the rest is just okay, so there's another thing that there's another term that I'm not sure if you're introduced to when you were in lower sec, is collinear. Okay, when 3 points lie on the same straight line, we call them collinear points. You know, we say colleagues, company, all the co, right, just means they are in a partnership. So when these 3 points, they lie on the same linear line, we call them collinear points. Can it be more than? More than, can. Any other points they give you. But usually they won't give you so many. Yeah.
Is 2 considered?
2 points?
Is it considered collinear?
We can say that also lah. But usually they give 3. Yeah. Can. But usually we use for 3. Okay, shh. Next question say I have a line segment. Okay, you know line, right? They shoot to infinity on either end. But when we say line segment, it's chop up.
So it's like A to
Yes, so from 2 points, let's say P and Q, we say this is called a line segment, a segment of the line. Okay? So when they say line segment PQ, they are referring to this one. And it says that it intersects the y-axis at the point R. So y-axis at the point R, I don't know what is the y coordinate, but for sure I know x is 0. I just didn't know what is the y coordinate. Yes. Okay, line in our understanding, it is an unstoppable line. So it will extend infinitely from both ends, like the Incredible like that, right? So both ends will go all the way. But when we say line segment, it chops up the line with two endpoints. So like P and Q is a line segment. One segment of that line. So it is finite. Okay, but line is infinite. Okay, so you just need to know the terms they use has a meaning behind it. Yes.
So you can say a line never ends.
Yes.
But if you never start, so it's basically a line. No, it's like, okay, imagine you have like an infinite line. Like infinity going there.
Okay, so if I want to find the coordinates of R, how will you approach this question? Sub x at 0 where? If you have the equation of the line. Okay, but if not, is there a quick way? These are also collinear points, right? The 3 points that is on the line. You can also use gradient to help you. So you can set up the equation. Gradient of PQ is equal to gradient of PR. It's also equal to the gradient of RQ, but I don't need to have so many. So I set up my first gradient. I use 4 minus 6.
Then negative 3 minus 9.
Yes, negative 3 minus 9
is equal to
is equal to my PR, right? So 4 minus y over negative 3 minus 0. Always start from y. Y is on top. I have so many batches of students doing gradient with difference of x above. Then all your answer is opposite. So don't do that. 10 minus 12.
Oh yeah, there's minus.
Okay, then you go and cross multiply and solve. Okay, this one, if you don't want to do both crossing, you can just multiply the 3 over.
So it's 30.
Correct, right?
30.
So minus 15.
5. Wait. 30.
19.
30.
So R is 0, 19.
Wait, 2, 5. How do you get?
You press calculator. I don't have calculator. That's why I need to mental sum.
Should it not simplify? Should it
You can cross multiply also.
30 divided by 4. It's 15 over 2.
Did I miss out?
Yeah, it's not. You can't simplify it to negative 15.
4. Oh, this one I cancelled already.
It's 15 over 2.
50 over 2 or 5 over 2?
1 over 15 over 2.
5 over 2, right? Okay, my bad.
Wait, no, it's 15 over 2. How do you get 5 over 2 as well?
The 3 I cancelled already, right? You press calculator, can? This one.
Yeah,
3 over 2.
yeah. No, 15 over 2.
Correct, right? My answer correct. Okay, wait. One more time. Press this using your calculator. Correct, right? Okay. Then I bring the y over minus 2.5, so it's 1.5.
Actually, what are you calculating?
Wait, hold on.
What?
Okay, I don't cancel here. I just put like that, okay? So this is your coordinate of R. So 4.1, just like that. If they tell you collinear points, they never say they lie on the straight line. You must know it means it lies on the straight line. They have the same gradient. So the only thing about collinear points is that any 2 points, they share the same gradient. Okay, so that is the only probably new thing here. Other than that, that's it for all good. Can, right? 4.1 is very direct. Wednesday, straight after school, should be okay. Yeah, can. Why? Which one? Which one? 5? Example 5? Oh, can? You can just see me after school today. Why must wait until Wednesday? I move on already.
I don't believe you're right.
4.1. Okay, this one. Shh. Okay, this one. Also very easy. Okay, listen. Shh. Okay, listen. They want you to write this equation out. You just y equals to mx plus c. Like that only. Okay, noisy, So you just need to see, put in the gradient, then put in the y-intercept.
Wait, Miss Wong, is this just the y equals?
Yes, that's all. So if I give you gradient, I give you y-intercept, sub in. That's all. But you know in life it's not so easy, right? They will give you 2 points. Ask you to find gradient, ask you to find y-intercept, then get the equation. So all this, even if I were to write it out, writing the equation out shouldn't be a problem. Okay? So all this got no C. Because it all cuts through the y-intercept, it all cuts through the origin. That means all this line, right? This one is a downward sloping line. The y-intercept is at 0. This one also, but gentler. Okay, this one is just the horizontal line here. This one is going up. This one steeper. But all of it, the commonality is that they all pass through the y-axis at 0. That's why it's all 0. Okay, so they ask you which of the equation above represent a line that passed through the origin. So if you look, actually all the equation from E to I. All the equation from E to I, because C is equal to 0. So when C is equal to 0, it cuts the y-axis at 0. So it passed through the origin. Then they ask you which equation represents a horizontal line. Horizontal line means gradient must be 0. So if you look at all the equation, only G. Okay, because M is 0. Then the last thing they ask you, how do you use an equation to represent a vertical line? What is its gradient? So vertical line, the gradient is undefined. The equation to represent vertical line is like line of symmetry. Is x equal to A. So this A is wherever it cuts the x-axis. Okay? So that's it. Okay, we shall continue on Thursday. But if you want, you can go to the next page and try the question. It is all doable. You have learned this already. Okay, but go and do up the quiz so that I can have a look at your work. But if you have done the online one, it's okay already. So those of you with the 10-year series, you can go and practice your A math partial fractions and you can practice your E math indices. Okay, on your 10-year series first. Don't wait for my revision paper.